Hi there. Now let's start with a new section, grouping data. In previous lessons, you learned some important group functions. These should help you to calculate the average of the returning values, the maximum value, the minimum value, and the number of returning rows, etc. So let me open up the SQL Developer first. So here, what do I need to write to get the average salary? To do this, as you remember, I just write select AVG salary from employees. You already know this. This is the average salary of all the employees. But what if I want to calculate the average salary of a specific job? For example, the IT programmers. That is simple. I just write a where condition, where job ID is equal to IT prog. There is no problem. However, what if I also want to calculate the average salary of the sales representatives as well? Should I add or job ID is equal to SA rep? No, because it will return one row and this will be the average salary of all the employees whose job IDs are equal to IT prog or SA rep. No, this is not what I wanted, because I want the average salary of the IT programmers besides the average salary of the sales representatives in another row. But this query returns the average salary for all of them in one row. On top of that, what if I want to show the average salaries for each job ID in a single query? For example, IT prog and its average salary, SA rep and its average salary, SH manager and its average salary, and so on. Is there any way to do this? Yes, there is. That's where the group by clause comes into play. The group by is a powerful clause, especially when analyzing large amounts of data. It allows us to create groups of values using the group functions. As you know, the group functions return values for a group of data. But until now, the whole result set is considered as a single group. So the aggregate functions returned one row for the whole rows, as you remember. However, adding the group by clause splits the result into smaller groups, and the aggregate functions are applied to each group individually. I want to elaborate it. The group by is used for grouping returned rows by the query into logical groups. So let's take a look at how we use the group by clause in the SQL queries. We write column names or expression here and our aggregate functions. It can be any group functions such as sum, count, min, max, etc. And from table, and write the where clause if necessary. And then the group by clause. The group by clause comes after the from clause. If there is a where clause, the group by clause must be placed after the where clause. And after that, we write our expressions in the select statement. But one thing to note is that the columns or expressions that are not encapsulated within an aggregate function must be written in the group by clause. This is really important. However, the columns or expressions written in the aggregate functions don't need to be written in the group by clause, because they are already grouped. I mean, the rows are grouped by the columns in the group by, and the aggregate functions perform operations on these grouped rows, so they don't need to be grouped. We just need to write the expressions that are not encapsulated within an aggregate function in the group by clause. Of course, we can write it also, but that is not necessary. And lastly, we can write the order by clause if you want to sort the result. As can be seen here, we can write more than one expression or column in the group by clause. This means that we can group the rows by more than one column. You will see that on an example in a moment. And as you can see, the select clause cannot have any different columns than the ones used with the group by clause. Otherwise, you will have an error. And we don't need to use all the columns written with the group by clause in the select statement. As you know, all the individual columns written in the select statement must be in the group by clause. However, the opposite is not necessarily true, because grouping the rows and showing the grouped results are different. You will see an example of that soon. And we can use the group functions with different input columns in the select statements than the group by clause has. As I mentioned, the group by groups the rows, not the columns. However, the group functions operate on the columns in the grouped result. So in this way, you can use different columns as well with the group functions. And we can use as many group functions as we want. There is no restriction on the number. And we cannot use column aliases with the group by clause. As you remember, we can use the column aliases with the order by clause, but we cannot do this with the group by clause. The order by clause cannot have any other individual columns than the group by clause has, but it can be within the group functions. This is also an important thing to remember. If you try to use an individual column that the group by doesn't have, you will have an error. So you should be careful about this. And like I said before, we can use the where clause to restrict the returning data. However, we cannot use the group functions in the where clause. There is another method to do this, and you will see it soon. So these are the important rules that you should know while using the group by clause. So let me show you these rules on the examples to cement them in your mind. As I mentioned, the group by clause groups the rows with the given column or column list. Let me show you an example of this. As you remember, at the beginning of this lecture, I had asked you, can we show the average salaries of each job ID in a single query? Now you know that we can do this using the group by clause. To do this, we write select and the column name that we want to group with, which is job ID here, AVG salary from employees. And after that, since this query doesn't include a where clause, we can directly write the group by clause. And after the group by clause, we just need to write the expressions or columns that we want to group our result with. In this case, I want to group the rows by their job IDs. And lastly, I want to sort the result using the order by clause by the average salaries. As you can see, we can use the group functions in the order by clause. And if I show you the output of this query, you see that the rows are grouped by their job ID values. So the average salaries for each job ID are returned. And they are sorted in ascending order, which is the default order. So let's see this in the SQL Developer. I write select job ID, and I want to get the average salaries for each job ID, so I write AVG salary from employees. If I run a query like this, we get an error. Because, as I said, we need to write the expressions or columns with the group by clause that are not encapsulated within an aggregate function in the select statement. So to get rid of this error, I write the group by clause and job ID here. Since we don't need to write a where condition here, we can directly write the group by clause right after the table name. And if I run the query, as you can see, all the job IDs are returned with their average salaries. And if you noticed, they are unordered. If you want to order the result, you can sort them using the order by clause. So let's do it. I write order by, and let's order the result by their average salary values. So I write AVG salary. They are ordered in ascending order. If I write DSC here, as you can see, this time the result is sorted in descending order. Perfect. Now let's turn back to our slide presentation. And continue with the next slide. We can use more than one column in the group by clause. This is also important. If we see an example of this, you see that we have 3 columns and one aggregate function in our select statement. and I need to write all these three columns here with the group by clause. Actually, this is not the correct approach for the group by clause. I mean, we need to group the rows depending on our needs. However, it's the fact that we cannot use any other column than what the group by clause has unless we use them within a group function. So while using the group by clause, you need to write only the column names that you want to group in the select list. I wanted to elaborate this a couple of times because this is critical information that you should know. Well, in this example, I want to group the returning rows by multiple columns. You see that we want to group the rows by their department ID, job ID, and manager ID values. And if I show you the output, these rows are grouped by their department ID, job ID, and manager ID values. By the way, changing the order of these columns in the group by clause may change the order of the returning rows. But this doesn't change the result set. I mean, the rows will be the same except for their returning order. Actually, the group by performs grouping by some sort operations, but it is usually a binary sort, so this will not be a standard sort. Besides, there are many reasons that affect the behavior of sorting in the group by operations. So in fact, why or how it sorts the rows is not important at all. Because if you want to see the results in an order, you need to use the order by clause. The reason is that the sort in the group by operation is unreliable. Alright, now let's open up the SQL Developer and work on an example together. I write select job ID, department ID, and AVG salary from employees. After that, I add a group by clause and then write the columns that I want to group the rows. So I write job ID and department ID here. And if I run this, as you can see, we can write multiple columns with the group by clause. Or let's add a count star function to the end to sort the result by the number of rows in the groups. And write order by count star in descending order. Let's run it. As you can see, many job ID, department ID combinations have a count of more than one, and these are their average salary values. For example, this row shows that 29 rows have the same job ID and department ID. Similarly, 20 same rows have this job ID and department ID. And it goes on like that. Also, you can add more columns if you need to. Let's add the manager ID column, for example. And as you know, now I need to write this column with the group by clause as well in order not to get an error. So I write manager ID here too. If I run the query again, as you can see, this time we have grouped the rows by these three columns. There is no problem. We can use the group by clause with multiple columns. However, if you group with more columns, the returning result may change, because now you group with more rows. So the possibility of the same rows having all these columns may decrease, and this might increase the number of returning rows in the result set. So what if I change the order of the columns in the group by clause? Let me show that with an example, because I see many students have problems with this. For example, let's delete the order by clause and run the query. Let's pin this output and change the order of job ID and department ID columns, for example, and execute it. As you can see, the order of the returned rows change. Actually, the returning rows don't change, but the order of the rows may change. The reason is, to group data, the database server performs different kinds of sort operations, but these sorts are not reliable. There are many reasons that can change the behavior of the group by clause while sorting data. So usually it will not be sorted properly. So if you want to see the rows sorted by some columns, you need to add the order by clause to your queries. Actually, as you see, it is not sorted properly here as well. Alright, now let's have a little break here. In the next lecture, you will learn more about the group by clause. So bye for now and see you in the next part of the lecture.